In this video, I'm going to be telling you how to answer the resolving vectors question in your final mechanics exam. The question looks something like this, and it comes out every single year. So if you want to learn how to get this down and get 100% on this question, then stick around for the video. Okay, so here's the worksheet, and it's a collection of all of this style of question. You have many examples of this question. You can see they all take the same sort of form. They give you all these different vectors, and then you have to basically resolve them, find resultant vectors and stuff like that. But we're going to go through two examples, really good examples of this style of question from this worksheet. But you have all of those there, and I've answered the odd questions, so I've answered all those, put written answers for them, and then we've also got some extracted answers for the even ones. So you have all the answers there and all of the many examples of this style of question. But in this video, like I said, we're going to go through two good examples of this question. We're going to go through it in detail, in depth, so you really understand it, get a grasp for the style, and so you can get 100% on this question in your final exam. And then after that, we're going to, as a sort of reward, we're going to actually talk about forces in a much deeper sense and start to get you to look at force as something a little more than just an arrow on a piece of paper. But anyway, so we'll just jump right into this by doing some questions. So both of these are extracted from that worksheet, and you'll be able to download that in the link in the description. Okay, so let's just do this. So what they like to do, they give you this diagram with different vectors, and they will usually ask you to find some resultant force or find some other vector if the vectors are in equilibrium. And we have both of those examples here. So we're going to do this one first. So we've got these forces here. So the first thing I always like to do is, and I've always said this in many of my videos, is I like to redraw the situation because it helps me understand and visualize what's really going on. So it's just what I like to do, and I would recommend that you do this too with all maths and physics questions. Okay, so I'm redrawing the situation. So we've got this, and then we've got this angle here. Oh, not infinity. Okay, and this is at right angles, and it'd also be good to note, well, this is the x, this is the x axis, and this is the y axis. I'll put the y up here. It's conventional. Okay, so it says that we have these three forces, coplanar forces, which just means they're all acting on the same plane, so they're all acting on this two-dimensional plane, and the directions are shown. It's also given here that tan alpha, put it a bit lower, tan alpha equals to 5/12. So that means that we can actually find alpha. Let's put this in your calculator. So we can find this angle between these two vectors. So 5 divided by 12, shift tan, which is 22.62 degrees. 22.62 degrees. So it wants you to find the magnitude and the direction of the resultant force of these three vectors. So these three vectors are acting on a point, they're sort of pulling in these different ways, and there's going to be some resultant force which moves some resultant vector, and we need to find that resultant vector. And really the key thing you need to understand here, well, this resultant vector, I'll call it R. It has these X, what I'm going to call Rx and Ry components. So this is the X component and the Y component of our resultant vector. And these components, Rx and Ry, are equal to the sum of all of the X components of these three vectors and all of the sum of all the Y components of these three vectors. So you'll see what I mean by that in a minute. So what I'm going to do here, first of all, is I'm going to call this vector A, this one acting at an angle. And, this vector A, just like our vector here, this has X. Remember, AX is just the X component because a vector is made up of the X and Y components, and then has, acts in that direction in the X and then in the Y. So this is your AX and your AY. Okay, so what we can say here is that the resultant vector, the X component of the resultant vector, is going to equal to the X component of this vector plus the X component of this vector plus the X component of this vector. So what is that? Well, the x component of this vector here acting straight up is 0 because it's acting completely in the y direction. So we can say this is 0 plus the x component of this second vector here is 31 because it has no y component and it's all acting in the x direction. You can see this here. So you can say it's plus 31 and it's in the positive x direction, so it's plus 31. And then we can say here for this vector a, which I called a, and just to make things easier, well, we're going to have this vector here is going to have an x component and a y component because it acts at some angle. Okay, and that's given by these, and we can find those. We can say that this is a sort of right angle triangle, and we can say that this here is the AY, well this is the y component of our a vector, and this is the x component of our a vector. So the x and the y make this a vector up. So how do we find this ax? Well, we can say that the cos, so we have opposite, adjacent, hypotenuse. We can say that from here we can say that cos of our alpha equals to the adjacent, which is the ax, divided by the hypotenuse, which is 26. So that gives us an equation for ax. So this would be plus ax, right? So the x component of the first one, x component of the second one, and x component of the third one. And we know that our ax from here, well, we have that cos alpha equals ax over 26. So therefore, ax equals to 26 cos alpha. Remember, alpha is this. So this is going to equal to 0, which is 31, plus 26 cos alpha. And you know, I probably should have mentioned this, but the reason that we're trying to find this R vector, this resultant vector, because once we find this resultant vector, we can find the magnitude and direction of it, of the resultant vector. So we find this resultant vector, we find the x and y components, then we can find the resultant, the magnitude of it, and then also what direction it acts in. Okay, so well, this equals to 31 plus 26 cos of alpha, which is 22.62. Okay, and again, this is plus as well. This is just important to know. This is plus because this ax is acting in the positive x direction. So this is cos. So that comes to 55. Okay, so the x component of our resultant vector is 55. So we want to find the y component. Well, this is the sum of all the y's components of all of these different vectors. So what's the y component of this vector? Well, this is positive 58 because it's all acting in the positive y direction. Plus, what's the y component of this 31 newtons here? Well, this is just going to equal to 0 because it's all acting in the x direction, nothing in the y direction. Plus our ay, which we need to figure out. Okay, and our ay, through the similar process here, well, the ay is just going to be, we know that sine alpha equals our ay, our opposite, over hypotenuse 26. So we can say that our ay, you know, from here, if we times by, is equal to 26 sine alpha. But remember, we have to take direction, and because this ay vector or component is acting down in the negative direction, this is negative. So we can say this is a negative 26 sine alpha. So this becomes 58 minus 26 sine alpha. Remember, our alpha is this. Okay, so we can do 58 minus 26 sine 22.26. So this equals to 48.115. We'll just do 0.2. This is Ry. Cool, so now we have this resultant vector. So the resultant vector is 48.2. 48 actually. So it's 48. I did the calculation wrong. So R is equal to then 55. Oh no. Yeah, 55. So our Rx is 55, and then our Ry is 48. So now we have this resultant vector. So we have this R, and you can see it acts positive 55 and then positive 48. So it's sort of acting in this way on the diagram. So the resultant vector is somewhere this way. So now if we want to find the magnitude of this, well, we have this resultant vector. We can call it R. And remember, it's got these x and y components. So we've got this Rx, which equals R55, and we have this Ry, which equals to R48. So if we want the magnitude of this, well, this is just going to be from Pythagoras' theorem. This squared equals, hypotenuse squared equals 55 squared plus 48 squared. So, we could say it's just square root. So we can do that. And we're going to get 73 newtons. Okay, so the magnitude of R is equal to 73 newtons. And then we want to know, well, what direction is this acting in? Remember, this is our x-axis. We can treat that as our x-axis. Well, what direction is this acting in? Well, we can say the tan theta equals to opposite, which is our Ry, 48, divided by adjacent, which is 55. So 55, 48 divided by 55. Shift down. And this equals to 41.1 degrees. So your theta equals 41.1 degrees. So you can say overall that you have your resultant, resultant vector has a magnitude of 73 newtons, and it's acting at an angle of 41.1 degrees. You can say it's acting at 41.1 degrees anti-clockwise. So you can say anti-clockwise from the positive x-axis, right? Because it's acting here, and this angle here is 41.1 degrees. And then it's got a magnitude of R. It's acting from the positive x-axis, 41.1 degrees. And that's your answer. Cool. Okay, let's do another one. And you're going to see this is pretty much, it's very similar, and all of them are actually very similar when you go through the worksheet. But this time it's at equilibrium, which complicates things a little bit, but not very much. Okay, so again, we've got this diagram, which I'm going to immediately redraw. So we've got this diagram here. Got 40 newtons. Got our x-axis. And then we've got this 32 newtons with the 20 degrees. 20 degrees. And then we've got this 17 newtons. And it's acting here, 55 degrees. So y-axis and x-axis. And then finally we've got this P here. So the Pn with theta. Okay, so that's the situation, and it's again, so these forces are all acting here on the point in the direction shown in the diagram, but the system is in equilibrium, and it wants you to find P and theta. Well, this time, because the system is in equilibrium, this means that the resultant vector of these four forces here is equal to, like we said before, has a y, rx, and a x and y component, but now this is equal to 0, 0. So now we can say that when we sum all of the x components up of those vectors, it's going to equal to 0, and when we sum all the y components up, they're also going to equal to 0. So we can say, again, and like I did before, what I like to do is I like to label these, so I can say this vector here is A, and A will have a x, an x and y component. This just makes it easier for me to express what I'm doing. And a B, we'll call this vector B. That has a bx, and by, and then I can call this vector here p. Remember, we want to find p and theta, which is the magnitude of this vector p and the angle at which it acts from the negative x-axis. And so our p is, has a px and a py. So we find this px and py, we can find our vector p, and then we can find p and theta. Sort of like what we did before. And I don't label this because I can see it's just a vector acting 40 up. I could label it if I wanted to, but I don't see the need in doing that. So our Rx is going to equal to the sum of all of these x components. So for the first one, so there's 40 here, well, it just acts straight up, so it has 0 of an x component, plus, our Ax, plus our Bx, plus our Px, the x component of this A vector, the x component of this B vector, and the x component of this P vector. Okay, so if we now calculate all of these, we can find, and remember this equals 0, right? We will have an equation that could be very useful. We're actually going to get an equation in terms of p and theta for this, and then for our y component we're also going to get an equation in terms of p and theta. Okay, so it was like before. So we have this A vector here, and it has a x component here and a y component. And if we want to find this Ax here, well, this is just going to be opposite adjacent like before. So the cos of 20 equals to Ax adjacent divided by our hypotenuse, which is 32. And the same goes here, but this you could do it from here, resolving it like that, but I like to do it from, keep it consistent and act from the positive x-axis, or the x-axis, sorry. So I'm going to say this is, 90 minus 55, so this is 35 degrees. So maybe we should move this, so B. So then your B, oh, what happened there? That's 20. Okay, so then this is your by, and this is your bx. Same goes for the p. You have your p, py, and px. You get the idea. So your bx here will equal. This might get a bit messy, but again, you've got your opposite adjacent, so it's going to be cos for bx. Cos of 35 equals your bx over the magnitude, which is the hypotenuse, 17. So you get the idea. So you can work all those things out from the diagram. So from the diagram, you can see that you have your cos of 20 equals to Ax over 32, the hypotenuse, and then we also have our cos of 35 here equals to the bx over the 17. And then we also have the px. Well, the px is going to be, our cos of theta equals our px, which is the adjacent, divided by our p, which is the magnitude or the hypotenuse of the p vector. So we have cos theta equals px over the magnitude of p. Okay, so we can arrange all these things. And remember, we have to take into account the direction. So for the Ax, this is acting in the positive x direction. So we can say this is equal to positive 32 cos 20. And then our Bx, well, the Bx acts in the negative, the negative x direction. So this is going to equal to negative 17 cos of 35. And then for the px, well, again, the px also acts in the negative. So we can say that px equals to negative p cos theta. Remember, we're trying to find these things. That's what all we're doing here. So we're trying to find equations so we can find these things. And they always ask something like this. Okay, so let's put all that into this equation. So we have 0, which you don't need to write. And we have plus 32 cos of 20 minus our bx, so plus bx, which is minus 17 cos of 35, and then minus p cos theta. And that all equals 0 because this is at equilibrium. So these are all the x components, and all the x components sum up to 0 because it's at equilibrium. Okay, so then you put this into your calculator. 32 cos of 20 minus 17 cos of 35. So you get that P cos theta equals to 16.145. Cool. So we have an equation with P and theta as unknown, so we can call that, let's call that equation 1. And then let's do the same for Ry, because again, all our Ry components will sum up to 0. So this is just going to equal to, well, what's the Y of this 40 here? Well, it's positive 40, right, because it's acting in the positive Y direction. And then for these, it's going to be AY, BY, and PY, which we'll need to work out. So this is plus AY, plus BY, plus PY, and that all equals 0 because it's at equilibrium. Okay, so then to find these AYs and BYs and stuff, well, it's the same thing, but instead of cos now, it's opposite over hypotenuse. So we can say that, you know, for AY, we have sine of 20 equals AY. And it's getting a bit messy here, but you get the idea. So you're just figuring out these components. So you got your AY, and you do the same here for your BY. Your BY would be sine of 35 equals BY over 17, and then you do your PY, where you get sine of theta equals PY over P. Okay, so you know, you do all those and you get, so I'll write them out. So you get sine, so you work this out, you get sine 20. Sine 20 equals AY over 32, and you get sine of 35 equals BY over 17, and then you get sine of theta equals PY over P, which is the magnitude. Okay, and then you obviously rearrange them, but you need to again take into account the direction. So for AY, well, this is acting in the negative Y direction, so this is going to be negative. And I just put it in, I don't know why I put it in brackets. I just put it in brackets to show, to emphasize its direction. Maybe that's why I do it. Sine of 20, and then you have your BY. Well, what direction is this acting in? Well, this is acting in the positive Y direction, so this is positive 17 sine 35. And then finally you have your PY, where your PY is acting, this Y component of P, well, that's acting in the negative direction. So you got negative P of sine theta. Okay, so let's put all that in. So we get 40 minus 32 sine 20 plus 17 sine 35 minus P sine theta. And I hope this is useful, me really taking my time through these instead of just whizzing through them. So you put that all into your calculator. Plus 17 sine 35. So I get that P sine theta equals, so I just worked all this out and then took this over, equals 38.81. Cool, so now we have another equation with P and theta. So we have two equations with P and theta. So two unknowns, two equations. Now we can find our P and theta. So I can see here that if I substitute, so if I just, if I rearrange this, you can say, well, you could say that P equals, if I divide by cos, 16.145 divided by cos theta, right? And then I'll substitute this into here. So we'll substitute 1 into 2. So I'm substituting that in. So we get 16.145 divided by, and the reason I did that because I can see you're gonna get a sine theta over cos theta, which will be able to go to tan theta. So I substitute this, so this equation, into here. Cool. So then I will say that we have sine theta over cos theta equals 38.81 divided by 16.145. And this gives us a tan theta equals that divided by 16.145. So this is 2.4036, and then we can find our theta. So theta is 67.4 degrees. And now that we have that theta, we can then find, so substitute the theta into here, we can find, so this is from 2, we can find sine 67.4 equals to 38.81 to find the p. So we get p equals to 81 divided by sine of 67.4. So it equals to 42. So 42 newtons, or just 42. So there, your P equals to 42. So 67.4 and 42 is cool. And that's two really good examples there of this style of question, which we went through. So you've got that worksheet, so make sure you go away, download that. I've got a bunch of my own answers on there, so you can really get a good feel for this question. But now we're just gonna, as a sort of reward, we've been through the technical stuff and got you to understand this. We're gonna now look at force as more than just a line on a piece of paper. Made myself a hot tea, green tea, to symbolize we're going to go a bit deeper. So in the video, what we did is we went through the technical skills that you need to do well in your exam and to understand this force, because we have this force concept to pass these questions. But right now what I want to do is I just want to explore force in a deeper sense and start to get you to see force as something a lot more than just an arrow on a piece of paper. That is a very superficial way of looking at it. What is a force? Man, what a question. Just the idea that I can enact force onto the world to manipulate it to get what I want. Look, let's take this mug. We had to deliberately and consciously apply force to mold this mug into existence for the purpose that I can drink a liquid from it. This was conscious force. Now, is that different from, let's say, the force between two inanimate objects? Is that different? Is there a difference between those two forces? I don't know, but I want you to become aware of these sort of things. Be aware that when you go through your day, you are constantly applying force externally to get what you want. You're opening the door, you're shaking someone's hand, you're making some food, you're eating. All of this stuff, you are using force, a conscious, or sometimes you're not even aware, you're just unconsciously doing it, force to get what you want. I want you to become aware of this, and you're doing this all the time, constantly. I also want you to become aware of the fact that you are being subjected to an unfathomable amount of forces. Think of all of the forces on all of the different levels, from particles to galaxies to everything, to all of this force just coming in at you, like you're just being put everywhere, and you just sort of found this divine balance, and you're just sitting here watching this video. You're able to move, you're able to speak, you're able to create. And that's the big thing that I sort of figured out about forces, is that force, conscious and deliberate force, is the medium for creation. Like I was talking about with the mug, everything around you has been made consciously through force. You have molded reality through conscious force for creation. Even think of this video, think of the words that I'm saying. All of these words that are coming out of me, the language that I'm speaking, this creation of language that I'm saying, is coming through my force. I'm contracting, and my airway passage and my tongue is moving in complex ways for me to communicate and create language for you. These are all minute forces happening. Is there a difference between your force, like willpower or stuff like that, force where you force yourself to do something? Is there a difference between that kind of force and the forces between inanimate objects? Is there a difference? It's a mysterious thing. It's very mysterious. Why is it that certain things are forced and attracted together, positive and negative. I know we can talk about electromagnetism, but again, it seems that that's a bit superficial. It's equations relating how they're attracted together, but why are they attracted together? Why is it that a positive and negative pole come together? They're forced together. Is there other sort of attractions going on? Maybe between male and female, or sexual attractions, or nature, or these are all sort of attractive poles, and there's these weird forces. Like, you can feel just sitting here, if you just sit here, you can feel the force of gravity. You can feel that you have weight. You know, this is a revolutionary idea. You know, think about the fact that we managed to understand, oh wait, I can put force onto reality to get what I want. A good example would be to think about fire. You know, imagine the people making that fire. They forced it out. They forced the creation of fire. You know, they forced it, and then it sparked out, and the creation sparked out, and that gave them warmth, and that gave them maybe defense against some animals or other tribes or whatever. But that they sort of they gained some sort of intuition there, like that they could through force they can create. And this is a very sort of mysterious and inspiring thing that we've managed to I'm going to use the word intuit. There's not really a way to explain. We understand that, oh, I can use force to create things in the world. And yeah, that's true. I just wanted to spend a little bit of time at the end of this video just for the sole purpose of just to start, you know, getting you to ask questions about this, you know, starting to think about force in a more open manner. You know, I feel like a lot of the time, you know, when it's talked about in science, this stuff is like very superficial. I'm not saying it's wrong, it's just that's one way to look at it. There's also other ways to look at it. And there's also different perspectives you can take on this idea of force. And I really want you to start maybe exploring those ideas, you know, during your study, because it can actually inspire you to learn about it more deeper and think about it, you know, because the more you think about it, the more you grasp it. Like, what is force? You know, you start asking those questions, and you know, you can get some really incredible things come out there for you and for your understanding. So yeah, I just really wanted to say that. But if you enjoyed this video, you found it valuable, please consider subscribing to my channel, liking this, and that's it. That's pretty much all I've got to say. Cheers. Thank you for your time, and I'll see you in the next video.